We live in a time of global transformation. The Energy Futures podcast explores how we can accelerate the expansion of clean energy technologies and reduce our reliance on fossil fuels. From heating and cooling our homes to moving around our planet and beyond, we bring together researchers, scientists, business leaders, and communicators to exchange knowledge and try to answer one important question. How can we create a sustainable energy future for all? This podcast is produced by Energy Futures Lab of Imperial College London.
In this episode, we're joined by Lior Suchoy, a research associate at Imperial College London. We explore geothermal energy basics, the potential of enhanced geothermal systems in achieving net zero, and Lior's journey into the field as a passionate advocate for geothermal and other renewable energy solutions.
Lior, thank you for joining me today. I've been really excited and nervous about this conversation because I have a baseline knowledge of renewables and energy and the energy transition and decarbonisation, but geothermal and other things that we're going to talk about today are a little bit out of my reach, and I'm guessing that people that are listening to this might feel the same. So we're going to do a little bit of what's what is it, but then also we're going to know a bit more about you and the work that you'll do. So I'm going to start with the question about traditional geothermal and what it is.
Okay, so you're right to say that like geothermal is in a way the unknown giant in the room when it comes to energy, and it's kind of funny because really in its potential it could be as big as, I assume, solar or one of the other ones, and the reason people don't hear about it much is because traditional geothermal energy is closely associated with specific regions in the world, specific types of geology that just doesn't exist in many places. And the expansion of geothermal energy to, say, places like the UK or most of Europe, which is the areas that green energy is mostly promoted these days, this is relatively new. So underdeveloped, but with huge potential. And we should say, when we talk about geothermal energy, what we're talking about is taking heat from deep underground, bringing it to the surface and creating electricity out of it. Well, I will talk about creating electricity out of it, but really you can just use it as heat, which is what has been done for thousands of years. So all of the, say, saunas in northern countries, from Iceland and Sweden, these are all geothermal extractions, right? It's water that got heated very deep and then got brought to the surface through some natural process and are then being used for the heat. In the UK, you can think of places like Bath or even the Peak District, where you have natural hot springs, and they have been used in the past. So it's an energy that had been used, but really to a very specific level until now. So traditional geothermal is extracting this water, or, well, it is water, from the deep underground, bringing it to the surface, so essentially just digging a well, bringing it up to the surface, and then using it. Either if it's really hot, if it's steam, then you can generate power out of it, or you can just use it to, say, heat your home or heat your roads, or as saunas in other places. So for this to happen, you must have a heat source that is close enough that you can dig and get it from. So for electricity, I mean, you want steam, right? For water to get to the temperatures of steam at a level where we not currently, but in the recent past could dig to, we needed some kind of high heat source in the ground, usually magma chambers. So if you think of a volcano, we all know about the lava that flows out of the volcano. But when this lava is underground, we call it magma. Now this magma, sitting in a huge chamber underground, in a way, it's sitting in a mesh and chambers and all kind of formations. But the important part is that it hits the ground a lot. Magma can be hundreds of degrees Celsius. So the water that flows close by to it will absorb this heat because they're under pressure, because they're underground. They will not just vaporize away. They will stay very, very hot, but still flow as water underground. And then when we dig a well and we get there, we can pump this steam up, use it to generate electricity. So that's how it was done for decades, I assume. I don't know when was the first time they started pumping this for the production of electricity, but I assume it tens of years, definitely. So that's what had happened until this point. Now, in recent times, and because, well, some new technological opportunities came, and suddenly we were able to dig deeper and dig horizontally, and we realized we don't have to find these heat sources close to the ground, like with magma chambers. There is the natural heat gradient within the earth, and we can take advantage of this. So we can pump, say, water from 3 kilometers, 4 kilometers deep that are less than 100 degrees Celsius, and use these water to heat all kind of things. So, for example, in the Netherlands, right, it's a relatively cold country, but they grow a lot of flowers, and these flowers, they require heat. So you dig 3 kilometers, you pump water out that are around 70, 90 degrees. You use this to heat all of your flower beds. And so this is a big supporter of the industry, because then you don't have to use natural gas, you don't have to use electricity for these heatings. It reduces costs significantly. And that is the main use of geothermal. Part of the problem is you don't always have water where you're looking for it. And sometimes you have water, but you can't access them because the medium, the rock that it's in, that the water are in it, is not porous enough. So you can think of your rocks not necessarily as these solid objects that you used to think of them, but think of them more as like sponges. So they have cavities in them, and these cavities allow fluids to flow through them. Now, if it's like a sponge, then you can imagine water will flow quite freely through your rock. But most rocks are not sponges. And so it's harder for water to flow through them. Sometimes it's easier, then we call it high porosity rock. Sometimes it's harder, and we call it low porosity rock. And if it's a low porosity rock, but it's hot enough, and we want the water to flow through it to extract the heat, we essentially have to break it. And this is what these new types of geothermal called enhanced geothermal systems. This is where they come. So you get to your rock, you increase the porosity in different ways, and I think we'll discuss these later. And then you either pump the water that is already there, but in most cases you will have to also pump cold water in order to extract the hot water out, because essentially you just don't have enough water there.
Amazing. There was a few things that came up when you were talking. So obviously it sounds like it's very location specific. So we talk about what the benefits that countries like Iceland have in terms of the rock formation and how they can access heat and water and steam, etc. But you also mentioned, if we sort of pivot back to the UK, I think you mentioned Bath and the Peak District. What's different about Bath and the Peak District that's different from anywhere else? What's unique?
Well, it's not different than anywhere else. It, like any place on the earth, it has its unique geological features. Actually, these two locations are just a manifestation of something that is much more widespread. So there's a study by the British Geological Survey that looked at the rocks that feed those hot springs, and they looked at how widespread they are. And they're essentially all over the Midlands and in many places also in the south of England. So it's not unique to those two specific locations, but it's true that in between you can't really find those rocks. There are several things that have to come together for a hot spring to form. So you need to have the right amount of water, right? So without water, you won't have any spring. This water needs somehow to get hot and also to access the surface, which doesn't tend to happen a lot together, right? So if the water is deep enough underground that it gets hot, it's usually too far from the surface to be able to get to the surface. In these two specific locations, there are specific geological features that allow the water to get to the surface. But these are just, a manifestation of something bigger. So ideally, if we want to use this energy, we should not count those springs. This just gives us an indication that it exists. But then we, of course, have to dig and pump it. And I should say, it's an interesting thing because we had these skills of locating fluids underground and pumping them for a long, long time, because this is essentially our oil and gas industry, right? So this is what we do very well. We were not looking for water as much, although, when you need to access aquifers, then of course you do look for water, but not the same way you look for oil and gas. But if you think about those water resources for energy, then it's very, very similar to water and gas. To oil and gas in the way you search for it. So also,
and we still have the infrastructure to drill, to do these things. Could it move? Is there a potential to take the infrastructure from oil and gas, and rather than just stop that, but move that to heat and water underground? Is that a thing? Could that work?
That depends what you refer by infrastructure. So if what you mean is taking an oil rig and turning it into something that will dig for any kind of geothermal source on the ground, then the answer is clearly no. We cannot put an oil rig on the ground. It has to be a rig in the sea. But because these skills are very similar, then we don't really have to train that many people. If you ask people in the oil and gas industry, many of them are not happy with the carbon footprint of this industry, with the fact that it doesn't, in a way, I know many friends who would say that they do not want to work for a company that risks the future of their children. But they like the field, they have the skills, and this is the most clear path for them to move to something that is green, much more than, say, solar, much more than wind, because really what they're good at is locating things underground and digging for them. Some of the physical infrastructure can be used in both ways. So, if you have a drill, you can use it to dig for geothermal. It's not as straightforward because in the UK at least, we don't really dig for oil and gas on the surface. So on the land. We do look for it in the sea, and this is a completely different operation. But in other places, say in the US, in Russia, in many other places, they do dig a lot on ground, on land, and we can use these skills here. So yes and no to your question. We can use some of the infrastructure, but mainly the skills.
That's the great point I want to pick up on there, is the skills, because we mentioned the word transition. We're transitioning from one industry to one set of skills, and we need to move over. And I really like the fact that if we're looking, we've talked a lot about the green economy, green skills, and actually we should be, although we're going to stop drilling for
oil and gas and mining of coal. There is so many skills there in terms of, like how the drills work, how they get through rock, how they get through the land, the power it's needed to do that, but also the risks involved as well. There's lots of risks in doing this, and there need to be environmental impacts as well need to be thought about. Okay, that's really good, and I'm getting a really clear understanding of geothermal energy. What's also interesting, it's a way of generating electricity, but I also like it's also a process of not using electricity, because you're able to power heat your home or heat a building or whatever it is without using electricity. So you're kind of using less to heat your building. Is this where is this being used? And I always pivot back to the UK because that's where we live. But how many buildings or how many areas of the UK are you aware of that are using the heat from underground to heat buildings?
That's quite a complex question, because really you should look at different levels of the use of geothermal. So at the most shallow level, right, if you think about, let's say, top, tens of meters of the ground, we can use these for what's called ground heat pumps. And this is relatively widespread. I don't know if it's relatively widespread, but it's definitely in more than a few locations in the UK. And the idea is you have pipes going through the ground at below the surface, below the layer that heats and cools on a daily or seasonally basis. And so you get relatively constant temperature. That's the goal. And then usually this constant temperature is within the range of our comfortable temperature. So 10 to 30 degrees, somewhere there. And if you can then store water or some kind of other fluid that will then be pumped out to either heat your home in the winter or cool your home in the summer, you don't have to use either electricity or gas for that. So this is relatively widespread. I say relatively, I don't have the numbers in front of me, but it's definitely not a few locations. There are other ideas of how to produce heat. So, for example, there's something we mentioned in the conversation before was mine water. So we have a lot of holes in the ground in the UK. Many of these holes, or when I say holes, I mean, of course, abandoned mines. Many of them are flooded with water. And these water are sitting there for, I guess, many years, since the 70s, maybe slightly later. And so you can pump these waters. They are already in in the temperature of their environment, which is normally a very nice temperature, around 25 degrees. And you can use these instead of circulating water through the ground. Just use the hot water that you already have. Again, you don't have to heat it. You don't have to do anything with it. All you have to do is pump it. So there's some energy in getting this water, but not much. So that's another sort of type of geothermal. It's been explored. I think there is one use case. There is definitely one survey station in Glasgow. But I know that there are few groups in the UK that are looking into this. Again, this is a very localized resource. So if you have a mine next to you, this can be used. If you don't, then we're not going to dig a new mine in London specifically for that.
Talk me through the process of a mine that's filled with water. Then, what does it produce and how does it work? Just for anyone that, myself included, see how that works.
So, what mine is just hole in the ground, right?
Lots of channels of
Yeah, there was
corridors
there was a resource, usually coal, that you needed to extract. So you broke the rock, you physically took the coal out, and then there's a hole left. Usually, because water goes through the ground everywhere in the UK, these tend to get flooded. Not everywhere, but if I remember correctly, we're talking about 25% of the abandoned mines in the UK are completely flooded.
Yeah, I went to one in Derbyshire, Colwell Mines, and that was all flooded. Some of it you could get round through boats, but the majority was flooded, and we went for a trip round it. So I've seen that.
Yeah, that makes a lot of sense. And so these the water that are underground, because they're sitting at a constant temperature, and this is a nice temperature, you can just pump it out. You don't even need that much of a new infrastructure there, because when you dug the mine, water still came in. I mean, you had to pump the water out all the time anyway. So in a way, you just reuse the same kind of infrastructure you used before, but instead of taking the water and throwing it in a pond next to your mine, you then circulate it through either set of pipes going through the homes next to it, or some kind of a central, thermally isolated kind of pool that you can then use later in the year. But really, ideally, you connect it directly to the homes, or maybe not the homes. Maybe you connect it to the road. So in places that the road freeze, you can just circulate water under it. It's not drinking water, so it has to be properly separated from our current water supply. It can't just go through your boiler, because you won't be able to then use this hot water for anything. So there is some investment in infrastructure there, but if you think about it, the goal or the first places to use something like this will not necessarily be, say, terraced homes in many places. It will be, say, new estates. So when you build an estate, there is a lot of the infrastructure that is already centralized, right? You have, say, a single heating room for the entire estate, and then you just, instead of having boilers in every one of the apartments. So in these kind of conditions, it's very easy to then use things like mine water. So,
and you build the estates above the old mines?
You can.
Or near, at least?
There are problems with building things on top of mines, because especially if you pump the water out of it, because you can have the ground slightly decompressed or compressed. So essentially, you have a hole in the ground, and the ceiling falls down with time. So I'm not sure you can build on top of the mine, but once you pump the water out, you can move it away. There is the question of thermal isolation, so you have to have a proper piping system that is isolated from the surroundings, but these are things that we're doing anyway in other places. There's no new technology that is required to do something like this. I guess if you had a mine somewhere, there was already a village or a town next to it where people used to live. So you don't have to move it very far away to get to people. In these places, yes, it's classical to build new estates and then bring the water to it. You can also refurbish existing estates. So I know that many of these, the communities that live next to mines, were built initially as sort of group housing. So some of them will definitely have centralized systems that can then be refurbished and being used with mine water. But again, mine water is just one example. You can do the same with ground heat pumps. So a ground heat pump could be used anywhere in the UK. And it's I actually lived in an apartment for about a month that had not a ground heat pump, but an air heat pump. Similar idea. But there, yes, the entire estate had the one source of heating, and it just constantly kept the place at the same temperature.
And just to separate, there's a difference between a ground heat pump and a heat pump.
Yes.
So a ground heat pump taking heat from the ground, and a heat pump takes the heat from the air and pumps it into the house.
I mean, we're not going to discuss the what most people refer to when they talk about heat pumps, the air heat pumps, but it's a different kind of technology. But what I was referring to is the fact that this is also now being used in centralized kind of settings. Usually, you won't have it for every flat separately. But of course, technology advances all the time, and I guess even today you already have these kinds of systems that are for a single flat or a single house or so on.
Does it work better for new builds, new estates? Can you imply? Can you do this with existing buildings and estates and houses, or does it tend to work better on the new builds, do you think?
It's a very good question. Okay, I think for new builds, it's if you start from thinking about this as part of your infrastructure, it's definitely better. But I think it can be relatively easily woven into existing infrastructure. I'm saying this because in European countries, it's already happening. You have whole villages in Germany, for example, that are using this kind of heating. The road heating, which I mentioned before, this is already being used in Northern European countries. So these things, the villages and these places existed there before we had the technology. So really, I guess if you plan for it, it's probably cheaper. It's probably better in the sense that it utilizes the heat better. But there's no reason not to use it for existing houses. And considering the fact that in the UK we have to go through a project of insulating our homes. So anyway, there's sometimes on the horizon there's going to be a big project of renovation through the entire country. There's no reason why thermal energy from the ground in different forms cannot be part of it.
Okay, brilliant. Absolutely demystifying all these things for me. You're doing an amazing job. Thank you. There's one I want to just go back to here, and because we've talked about pumping water or pumping hydro, so we kind of like just to understand the difference between this and pumped hydro. So what the core difference is between pumping water for energy, because pumped hydro is a different thing, isn't
it? Yes.
Okay.
So these are actually, if you think about it, one will be a heat source, and another is the battery. So, and these can work together, although it's very rarely working together. So what we're talking about right now is getting heat from the ground, bringing it to the surface to be used. Piped hydro or piped hydro dams, these are high places where you store a lot of water. You use cheap energy to bring the water upwards into your reservoir. And then when you need the energy, say at peak times or something like that, you drop the water through a channel or a shaft. And that helps you then this turns a turbine, and the turbine then brings electricity to your grid. So really what you do is you store energy, right, in the form of using gravity, and then you're using it when you need it. This is very different than just extracting energy from somewhere else. Again, this can work together because all you need for pumped hydro, is a cheap form of energy to bring the water up. And this can be, not for heating, but this can be geothermal that is used, say, for electricity production, which is another topic we should discuss at some point.
Of course. So the water with pumped hydro, also it needs altitude, needs to be higher.
Yes.
So that it can then fall down and then generate the electricity. Fantastic.
Yes.
Okay.
And another thing to say about this, so pumped hydro is great for specific cases. Not so much for flat countries, and not so much for the communities that live up on the mountain. So, the dams and water reservoirs are anyway a point of controversy with the communities that live where the lake will form. Having a lot of those pumped water reservoirs where water level comes up and down all the time will definitely destroy the entire ecosystem around it. So it's not without its controversy having those pumped dams, but no energy is without its controversy. Not even geothermal, definitely not solar and wind. So
they all come with environmental impact, isn't it? It's like, how do you mitigate that, and how do you understand it and reduce it? Again, that's why they call them wicked problems, I suppose. So we're going to talk a little bit about enhanced geothermal systems, which is we might refer to it as EGS. And I've noticed that you've just smiled when I've mentioned that, because I think this is more an area that you're quite interested in, you're excited about. So tell me about enhanced geothermal systems. What are they and how do they work?
Sure. So the reason I'm more excited about it is just this is more of my everyday work. This is where my research coalesce with geothermal systems. So the idea, as I mentioned at the beginning, is that instead of just pumping something that is already in the ground, you have to actively create the infrastructure underground. You have to break the rock, then you have to provide the water, then you pump it out. The advantage of this is that you're not dependent on the temperature of the water that exists. You can decide, I want, say, water at 170 degrees, which is the target water for steam, for example. And then what you do is, once you know the temperature, then you figure out the depth that you need to dig to. Then you figure out, okay, do I have a rock that is now at the right temperature, and can I move water through it to pump this heat out? So this is where the enhanced come from, because we are creating this infrastructure in the underground. This is the place where geothermal actually becomes relevant for the national infrastructure. So until now, we talked about heating, and that's more local, say regional infrastructure, even down to the level of your home. When you talk about enhanced systems, you're looking at the level of a county to a country. And this is where it's really interesting, because this is where we have a big opportunity for decarbonizing our entire grid. And that's great. We can do it all through geothermal, of course. But geothermal, unlike, say, solar and wind, it provides a baseline. So if you hit the hot rock and you pump water through it, for the period that this operates, you have a constant supply of hot water that will have a constant supply of electricity, assuming there are no failures or anything like that, which are not likely. So as I mentioned before, we dig for a very long time. We know how to handle those failures. So it's not likely that it will fail constantly, not like, say, solar that fails every night when the sun comes down. And it gives you this baseline that you can then use solar and wind to get to top it off for your daily use. So in a sense, it has to be a mix. Like, it's in a similar way what people argue for the transitional use of natural gas. Right? People say, well, until we get to the capacity that we can store enough energy from solar and wind to be used when the sun don't shine and the wind don't blow. Until we get to that point, we will still need natural gas. And really, there are other answers like geothermal to get over this threshold.
So are you saying that it should be used as a part of the mix for the transition, maybe not for... Is it a sustainable way of generating energy, or is it more, do you think, in the meantime, before we can get to, well, not fully renewable, but as much renewable as we need?
It's an open question, because it's a reservoir of energy, right? You dig to the ground, you get to a hot rock, and then you start pumping water through it. The heat there is not infinite. Right, you pump the heat out. It takes time for the water to get reheated from the rest of the earth, and I mean, you want to pump the heat faster than the rock gets reheated. So I've seen studies that talk about typical reservoir lifespan of 30 years, 40 years, 50 years. But really, if you think of our oil and gas reservoirs, this is the same order of magnitude. And I should say, unlike oil and gas, really there are other ways of thinking about geothermal reservoirs that are more long-term sustainable. So for example, say you have a hot rock, right? You run your water through it, you get all the water out, now your rock is too cold. Maybe it's not 170, maybe now it's, say, 120. You then get your energy elsewhere, but you will still have those peaks of energy production because you will have solar and wind in your system where you have excess of energy. And kind of like hydro dams, where you store energy through gravity, here you can store energy through heat. So instead of putting into the ground cold water, then pumping out hot water, you can use these as just places to store hot water. And then you pump into the ground hot water, you heat it on the surface using your low-cost energy or your renewable energy. You put this in the ground, and then you pump it out when you need it. So there are ways of thinking about these places, these reservoirs, as more sustainable and long-term. This is not what I just mentioned. It's theoretical. No one had done it so far. I know they're talking about this in Germany, and there's I saw at least one paper talking about this potential, the potential for this in China. But as far as I know, it's not being used this way yet. But thinking of the long term, geothermal does not have to be viewed only as reservoirs. And there are other things as well. So if you now think of this as a storage place instead of a place you extract something from, really it can store all kind of things. It can store CO2, for example. So this CO2 has a lot of advantage over water. Mainly, it flows better through the rock, so you don't have to break the rock as much. If you don't get to extract all your CO2 in the pumping, all the CO2 you put in through your pumping, that's actually a good thing. So sequestration is great in that sense, unlike in geothermal systems where you actually want to get all the water that you put in back out. And that's just one example, right? You can put CO2, you can think of other things. You can maybe think of dissolve hydrogen in the water, which you can then maybe get back and extract hydrogen gas from. So whatever it is you need to put in the ground, you can then use those places for it. It's not ideal. It wasn't built for hydrogen storage. So for example, hydrogen as gas you will not be able to store it there because it's a tiny molecule to just flow through the rock. But maybe dissolve hydrogen you could. So there are ideas about what to do with those places, and these are not dissimilar ideas to what you'll do with abandoned oil mines, right? So we talk about sequestration in an oil mine as well, but because an oil mine was an oil well was not designed for heating, then you might not get your CO2 back when you pump it at the right temperatures to be used for electricity production. But really, here you can use it for electricity production.
I can see why you get so excited. I can see the smile on your face because there's so much opportunity here.
Oh yes,
and carry on.
No. I mean, yes, I should say there's a lot of ideas, but also a lot of challenges.
That's going to be my next question, actually. So let's talk through what are the barriers, what are the challenges, what have we got to overcome to make this a reality?
Well, everything, essentially. So as a concept, as an idea, it's great. The practicality of it is very difficult. So it's hard to dig, and we are still at the point where it is too expensive to produce electricity commercially from deep geothermal. It can be done in specific places. There are 2 sites in the UK that are doing it. There are, I think, 4 new power stations based on geothermal energy that are planned in the UK, but these are small power stations. So really, at the moment, it's very, very expensive, and we need to reduce these costs. We also need to reduce the risks. So there's a lot of things happening there, happening with geothermal that are uncertain. For example, we don't, if you think of what we do know about our underground, what were our main motivation to understand the underground, there was a high motivation to figure out the relatively shallow part, because this is where you had the old mines. There was a lot of interest in the very, very deep part, especially in the North Sea. So this is where you get your oil from. And there's this middle level of just a few kilometers that usually, it's not that it's been overlooked, of course. There's a lot of studies about this thing, but it wasn't thought of before as commercially viable. So we need more information about these levels, the amount of heat that is stored there, the specific type of rocks, how much are they fractured, how much or how will they behave once we start the process, which is where my study comes in. So really, there are a lot of unknowns that we still have to figure out. Again, a lot of money that has to come into research. So not just to get those uncertainties, but also to develop new materials. There's also the idea of economy of scale. So there's a lot of money that has to come in to start this industry in the UK. There are only a few companies, and they are relatively small. I mentioned before that in this industry you use the same skills as the oil and gas, and you may have a talent pool that is waiting to join the geothermal industry. But the geothermal industry at the moment is not even 1% in terms of jobs availability, in terms of investment. It's not even in the same orders of magnitude as the oil and gas industry. So it has to be started, and initial costs are always higher than running an existing system. What else? There's NIMBY, always. NIMBY, not in my backyard.
Okay.
So people do not like when you do big infrastructure projects in their backyard. With the oil and gas, it's fine because you're in the North Sea, no one sees you, or with wind, then you're out at sea, nobody cares as much. Try to convince people to put pylons on the ground, not so easy. Then trying to convince people to have all these small power stations everywhere, dotting everywhere around them, that's not so easy. So there is this problem. There's a planning issue, of course. So from the point of view of bureaucracy, we still don't have a easy enough process to create those new infrastructures. So yeah, there's a lot of things that still need to be improved. I should say a lot of people are looking at this. There are reports from the House of Lords. There are some reports from say think tanks and all kinds of organizations that want to promote this, but it's in infancy.
Okay. Well, there's lots of good points there, and I think in terms of the business startups, the 4 new small power plants that are like I don't want to call it experimenting, but trialing this, trying to kind of get this going, and also other research papers, and we can talk about, or we can add to the show notes. So if people are really wanting to do a lot more digging in this, see where it's going, that we can showcase that, and we can put that we can pivot them towards where that information is. You mentioned about your research. I'm going to kind of come to a close now, because I want to know a bit more about you, because you've had a very interesting background in terms of not just your own research and what you're working on now, but actually what you're interested in and where you come from. So tell me a little bit more about you. How did you arrive in this type of work?
By mistake. That's the right answer. So my background is in geology and physics, which then I pivoted towards tectonics, which had nothing to do with geothermal. So I'm looking, in most of my work had been looking into the hundreds of millions of years scale. So again, definitely not something that we want geothermal to be viable in this time scale. What happened was that I got into this postdoc kind of by mistake, because I was looking for a postdoc. This was free, and I was capable of doing the methods that were required without necessarily the right scientific background. So this is how I ended up doing what I'm doing at the moment, which is looking at what happens when you take cold fluid, put it in the deep underground where the rocks are hot, and so you put some stress on the rock just due to these thermal differences. What happens to the rock? How does it fracture? Can it be used, this fracturing, or should we avoid it? And this changes in different contexts. So we talked here about geothermal, where you, definitely with enhanced geothermal, you probably want to have more fracturing. That will increase your porosity, your permeability, and that will allow water to flow better from the pumping well into the extraction well. If your goal is different, say you want to put CO2 in the ground, and CO2 is very cold, maybe you don't want to break the rock that much, because then you might have a pathway to the ground, and then all the CO2 you put underground will eventually flow to the ground. So it depends on the context, but much of this work is in the context of geothermal. So we want to understand in geothermal system, how do they fracture, and can we use it? But really, my interest in geothermal was before I started this postdoc. It's just many of my friends who did the PhD with me finished their PhDs and then started looking for jobs. And all of them, the Department of Earth Science at Imperial had been traditionally very much associated with the oil and gas industry. But of course, people come in, they don't necessarily want to work in the oil and gas industry. They start looking around and they realize the best place for them will be the geothermal industry. It happened to me, it happened to a lot of my friends. I just took it one step further, started coming to conferences and reading about this topic and really learning more about it. Some of my friends have joined the industry or tried to join the industry, but many of them, if jobs will be available, will be happy to join in the future. I'll say it this way.
It's exciting, and I'm speaking to a lot of scientists, technicians, engineers, researchers that are moving from typical industries or research areas and moving into other technical ones because they have the right skill sets, they have the same passions, but actually they're using and leveraging those for other industries and other areas within sustainability, within energy, and it's innovating, it's creating great ideas, and it's creating new spaces, and it's the mixing of minds and the sharing of this kind of information and knowledge is just creating a really exciting time. And I think geothermal is an exciting time, and I hope that it doesn't take decades for it to come into fruition, but hopefully people like yourself are pushing it, celebrating it, championing it, but also passionate about it. So thank you for doing all this and talking about it.
I'm very happy to be here. I'll just say that there are many other people who are promoting these things in the UK and globally, many people with great ideas. If I remember just one talk I went to, someone produced a resource where they show on global maps the distribution of potential geothermal energy, which is wonderful. I mean, this is what you need in developing economies, for example, where you're now starting to hype up your energy usage. So this is, yes, it's still it's in infancy, but it's also being promoted by many people globally, many experts that know much more than me, definitely, but also by a lot of enthusiasts. So if it is something of interest, there's definitely a lot of resources to look at.
Amazing. And in terms of those resources, we'll come out to you and we'll see where the videos are, the papers are, the content. We'll put it in the show notes. But if people do want to know more and want to kind of find out from you about more of your work, or they'd like you to signpost them to other types of content, how can people find you? Where's the best place to contact you?
The best place is on my email, right. Which will probably be attached in the show notes. Just with all the workload, this is probably the place where I look most. But you can also find me on LinkedIn. I think this is also a good place for me to react. And I'm here at the Earth Science Department, so at least for the next few years. Drop me an email, come and visit, and we'll definitely, that'll be a great chat to have on geothermal.
Amazing. Thank you so much for your time. This has been very insightful. I've learned so much in the last sort of 35, 40 minutes, and I think we'll do it again. Let's do something else on a similar topic, and we'll get together and see where the industry's going and have another chat. But thank you so much for your time. I really appreciate it.
Yeah, I mean, there's so much to talk about. We haven't even mentioned lithium, so that's just a teaser for the next one.
Brilliant. Thank
Wonderful.
you. Cheers, Lior.
Thank you.
Thank you for tuning in to the Energy Futures podcast. Here at Energy Futures Lab, we are dedicated to addressing global energy challenges through pioneering research, innovation, and advocacy. To learn more about us and the exciting projects we are working on, visit our website and follow us on social media. If you enjoyed this episode, please like and share and subscribe to stay up to date with our latest content.